Hey guys, welcome to another episode of TinkChat. I'm your host today, Andy.
I'm Eugene.
And today we're going to be talking about the company for a bit first before we actually move into our topic of the day.
Yeah, the topic of the day is environmental applications, but I'm just going to step in for a split second and just give a bit of a highlight, if you want to call it that, as to just give you guys clarity what we do here at Tinkerine. We are a 3D printing manufacturing company. We're located in Canada. We've done all sorts of interesting little things, from 3D printers to composite materials to software. And this is a bit of a full disclosure moment because I don't think we've ever said what we did. So it is a bit of our interest to let you guys know about 3D printing. There is a gain at the end of the day for the company, both from perhaps a financial side, but these videos are meant to be educational.
Yes.
And it's meant to be inquisitive.
Mm-hmm.
And when COVID started, when we were covering all these COVID things, we ourselves got into PPE manufacturing.
Yes.
And we asked ourselves one thing: can we help? I still remember that conversation we had with the team. That one Friday. And I said, we're ready to go into this. Are you guys ready? And PPE became part of our business ever since then. Right?
Yep.
So it's a bit of an interesting scenario. PPEs for us will stay for as long as COVID is around. Yeah. And I just want to make that aware for anyone that's watching that maybe thinking that, we are a PPE or medical device manufacturing company. No, we are actually a 3D printing design company. And we took our skill sets, the team's skill sets, to build PPEs for the medical industry.
Yes.
We'll continue to do that. And we have taken a very Tinkerine approach. Best in class, right? Best of the best that we can think of. Whatever it's already out there, we want to bring it one level above. And we want to change the dialogue. The dialogue is that one-time single-use PPEs could probably be changed to multi-use, reliable, high-quality PPEs.
Yes.
And we ran into the scenario globally with regards to PPE shortage because we were throwing them all away.
Yeah.
And we don't think it's right. We want to change that dialogue, and we want to encourage other companies to think about that, right? We want to align ourselves with companies that think about that. And so, we're building these. We're going to continue to build them alongside our other products, the 3D printers, the filaments, and the expansion of products and services that we're going to go on that side. Some of which we've announced, and some of which are up and coming and have yet to be announced.
Yeah.
And so we're all super excited about those elements. I don't want to take too much time out of our TinkChat video, but it's a bit of a sharing of information with you guys. And I know that there are a whole bunch of different type of viewers that view these videos. There are the YouTube audiences that just view it and they think the content is interesting.
Yeah.
I definitely know that there are some investors that view these as well.
Definitely.
And we're aware of those. And so welcome everyone, whatever the background is, wherever you come from. These videos will remain educational.
Yeah.
They will remain informative, and we just want you guys to know what's happening in the industry and what we're doing as well.
Yes.
Okay.
So
on to the topic.
Yeah. So as we said earlier, the first topic, well, not first topic, but the topic for today, it's going to be about 3D printing and environmental applications, or any impacts 3D printing has on the environment. So I'm sure a lot of people are wondering, with all these 3D printers in action right now, is it actually affecting our environment, or is it helping it, or is it actually causing planet Earth to deteriorate faster?
Oh, I think there's many ways to look at that.
Yeah.
Green solutions for materials are being advanced all the time. PLA is a great material for biodegradability.
Yeah.
But it's also not very heat tolerant. So there are limited applications for that.
Yes.
But we've seen some really interesting things, some of which we saw in some of the articles we pulled up. And so, I mean, why don't we go through some of them?
Yeah. So actually with 3D printing, one main thing right now that we went through in some articles was it actually reduces a lot of manufacturing waste. Versus the traditional where we actually have to shave off, like usually a block of material. All those shavings are usually waste afterwards.
Right.
Like 3D printing actually saves a lot because it just builds that from
whatever it needs.
Whatever it needs. So if your thing was 50 grams, it'll use 50 grams and there will be no waste in it.
I think there's maybe a need to clarify that a little bit. There is a little bit of waste.
Tiny bit, but it's insignificant compared to traditional manufacturing methods.
Yeah, and I think we saw some of this within the last couple of months.
Yeah.
Right? People are manufacturing things at mass.
Yeah.
Well, at mass in terms of 3D printing scales. Yeah. And getting ramped up to that phase to be able to make so much. I mean, prototyping is wasteful.
Yeah.
That's always going to be an element of waste in this industry. Because you're testing, you're fitting, you're form testing, you're doing all the tests, and inherently even we will generate waste by doing any of that. But when it actually gets to the point of manufacturing and you actually can produce it, the waste is absolutely near zero.
Yeah.
Right? Out of a tray or out of a build that is 100 grams worth, I think you'll get maybe half a gram of waste material out of it, which is none in the world of manufacturing.
So if you're thinking about that, 3D printing doesn't really contribute to landfills at all.
Yeah. End of life product thinking does come into play. End of life being once the product breaks or needs to be thrown away, then I can see that contributing. But plastic choices, material choices can change the dynamic of that quite a bit. Right?
But even with PLA itself right now, there are a lot of places that actually take PLA and recycle it and turns it back into filament. Whether or not those are reliable, because then when you recycle PLA, there's going to be extra random stuff that gets into it that could be harmful to your nozzle.
Yeah, detrimental to the performance of the product.
But still, you can still recycle everything that you built or all the waste that is generated from the printer.
Yeah, I think what's, for me, really cool about the impact, if you look at the impact side, 3D printing does one thing really well, or any digital manufacturing does one thing well, which is, we call it distributed manufacturing. There's many different names for this. Localized manufacturing is one way of doing it. One of the articles, I think, pulls it up, and they talked about the ability to send files from one place to the other. Yes. Not the actual physical thing, but the digital file.
The digital file.
Essentially the same concept of distributed manufacturing or localized manufacturing. And that saves a ton of stuff. It saves a ton of transportation. We talked a little bit about this in the last episode. Yeah, in the last episode. To go from one place to the other, you can just have the location B manufacture these things for you on site.
Yeah.
And so carbon emissions go down, transportation goes down. Yeah. So there is an environmental application or impact that happens when you start to look at manufacturing things this way. And it's actually not limited to additive manufacturing. It's actually limited, well, not limited, but it's actually within the realms of what we call digital fabrication.
Yeah.
So CNCs, advanced manufacturing tools, all allow for you to send files from one place to the other, for them to manufacture in this other place, for you to not even send a single thing over physically. So that impact, I think, is going to be pretty big. We're going to start to feel some of those impacts. Think about supply chain, just the global supply chain. Instead of sending like 1,000 screws, here's the file for your screws. Go ahead, make them. But let's talk. I mean, I think we've drilled down a little bit on that in the past. Yeah. Especially the last episode, we talked about that company who takes the files and they actually sell you the file and send you the parts. But the recycling of the materials is interesting.
Yeah.
Because PLA is a biodegradable material.
Yes.
And there actually isn't a lot of recycling plants that will take in PLA and biodegrade it down into fertilizer or whatever the base component is. There just isn't that much business behind recycling PLA. So there's actually a lot of companies that have sprung up to take waste printed parts prototypes, your failed prints, whichever, and grind it back down, put it into a machine, and they try and extrude out a consistent, clean filament for you to use, right? And there is an interesting element to that because every filament is manufactured with a different formulation.
Yes.
Not every filament is pure 100% PLA.
Yeah.
And so you end up with some very interesting characteristics, good or bad, we're not 100% sure.
Yeah, we won't know.
But we can recycle these materials, and we don't really know how many times you can because typically in recycled plastics, they mix a portion of the plastic that comes out with virgin material.
Oh, really?
That has never seen post-processing in the past.
Yeah.
And so, or heating up cycles of thermal degradation. So when you just use recycled material, I'm not sure what the implications are. But that's what a new industry is here to find out.
I mean, maybe Tinkerine can look into it.
Yeah, we thought about some of that. We've worked with some of our partners from post-secondary that have built filament recyclers. Yeah. And we're very interested in something like that because schools are interested. Yeah. We ourselves are interested from a commercial perspective. It may be something worth looking into for sure.
Yeah. So while we're still on biodegradable products and filament, there is this eco-friendly material that's actually being manufactured by this French company, I believe. They're called Francophil, I believe, or it's a French pronunciation. I have no idea because I'm really bad at languages. But it's very interesting because they actually use like oyster shell or coffee grindings or like mussel shells. And they use all those shells, I guess they grind it up, and then they make filament out of it.
Oh, does it have the scent of the actual materials?
I have no idea.
I think what's interesting is we've seen composite material.
Yeah.
We ourselves got into a bit of composite material. And the composite material on the filament side typically has a carrier base. When I say the carrier base, that's the plastic that actually holds everything together. And it's broken down into a ratio. So percentage material, percentage plastic. Yeah. My interest would be, what is that percentage material?
Yeah.
Because if it's 80% PLA, then it's going to act a lot like PLA. But if it's 80% material, well, we're talking about totally brand new space of biodegradability, because that is more biodegradable than PLA, coconut husks or coffee grinds or oyster shells or whatever that they use.
We'll probably pull up the site, and then maybe the information's right there.
Yeah.
But off my head, I don't think they
disclose the percentage ratio. And I think the industry needs to get a little bit more transparent with regards to some of those stuff. I think that actually helps determine material choices when you or I or a consumer is looking to say, I want the most eco-friendly material. And if it actually smells like coffee grounds, I mean, there's an added benefit of, well, I can make my house smell like roasted coffee when I'm burning.
Yeah. Right? Well, I remember, wasn't it a few years ago that someone came up with a bacon flavored?
I think it's proto pasta.
And when you heat it up, it smells like bacon?
Yeah.
Or was that April Fool's joke?
No, I think it's real.
Oh.
I think it's real. The industry of composite materials typically has been about scent and smell. Yeah. So like wood fill materials typically smell like wood.
They smell good. I like it.
Yeah, you may be the only person that does. You're not, because I know the internet does.
Yeah.
But it's unique.
Yeah, it's
right?
unique.
Because it's not just about the scent. It's actually about eco-friendliness.
Yes.
And I know a lot of even the wood fill stuff, it's like 5 to 10% wood fill, and it's mostly plastic in that situation. Right.
So mimics like wood properties.
It's hard. Because wood is not very dimensionally stable. It absorbs water.
Well, also,
and so filament
when you heat up wood, it's also not a good thing.
Yeah. So I mean, the really cool thing is the industry is looking at eco-friendly alternatives. Yeah. And I know even within BC, the landscape of BC, we've got a pretty heavy forestry industry. Yeah. There was talks about how to use, they call it the waste products, the off products that isn't dimensional lumber or anything like that, or like a particle board. Yeah. The off products, and seeing if they can actually put it into a 3D printing medium.
Mm.
So there has been discussions among the government level.
Yeah.
And even we were part of some of those discussions early on with how do we take this material that DC has abundance of and translate it into material that we can then use.
Mm.
So we're not alone in thinking about some of these things, right? And so, yeah.
Interesting.
Yeah.
So, okay, everything that we were just talking about previously, it was more about 3D printing and the impact onto the environment.
Right.
But let's move on to something that's more interesting, which is using 3D printers to help the environment.
Application.
Or application. Yeah, application. So this one article that we're looking at was actually talking about using 3D printers to help predict natural disasters. It sounds really out there, but essentially what they do is they utilize like satellites and everything to scan like the topography of the environment, and afterwards they use that data and they 3D print a model out.
Right, so they can inform the citizens of that location.
Yeah.
Where was it again? It was the article will say it.
Yeah.
But they get a lot of torrential rain. They get a lot of mudslides in those areas. And it's a way for them to inform, I believe, the citizens of what could potentially happen to the soil infrastructure.
Yeah, and it just gives a better visual. Because when you're first looking at a 2D map, you can hardly see what's the difference. Or if there's any danger in there, right? But with 3D printing in play, you can actually show the citizens, this is the danger spot. This is why we need to evacuate.
Right.
Or anything like that. So it's easier to communicate with a visual aid.
I feel like it's less about predicting a natural disaster than it is showcasing and natural disaster planning. Because I had a similar kind of question in my head was how would they, when I first saw the article title, I was like, how do they predict natural disasters? I thought they were using 3D printers, printing little things that they would throw into the sky and it would measure, it would magically measure weather data or something like that.
Yeah.
But it sounds like they're more utilizing the technology to show topography, which is the elevation of the landscape, and then using that to inform its citizens and saying, okay, so in the event of a natural disaster, these are the areas that we need to block off.
Yeah. Or
here is the infrastructural upgrades that we need to do to these places because the next time we have a giant monsoon, the earth is gonna the earth is gonna get taken out and we're gonna have a mudslide or something like that. And I think that's super smart because planning is a big portion of how 3D printing can actually help. Environmental, in terms of its application, is more civil than it is environmental, but it's closely linked together for sure. And I think it's a really cool way to use technology.
Yeah, who would have thought to actually utilize that? When I was reading it, I thought it was really out there, but apparently it works.
Right. Yeah, I think, we only know so much of what our background is. It just takes one person in any industry to say, hey, you know what? This technology can be applied this way, and we've never even thought of it before.
True.
For it to really take hold and have an impact in their industry as well. Yeah. Well, so the next topic is actually something that is a little more close to home for me.
Oh,
and this was me a while ago, like a long time ago. But it's 3D printing with regards to coral reefs.
Yes.
And I had a business prior to Tinkerine that was in the aquarium business, particularly saltwater, and we played a lot with corals and coral reefs and stuff like that.
But before you go into that, I'm sure everyone knows the coral reefs around the world, they're actually dying.
Right. Global climate change.
Yeah, climate change is causing them to die off, become extinct. So over the years, there's been all these efforts are trying to contain or try to revitalize it. Anyway, here you go.
Yeah. So before 3D printers came around, there was kind of already projects along the way that would build reef structures that would allow fish to come. And those reef structures were really hard to manufacture.
Like, how would they do it?
They would cast it. It would be out of cement. And it is still out of cement with 3D printing. Now imagine the house technology for this.
Yeah.
This is how they're using it.
But isn't it very difficult for you to actually make all the grooves and everything?
Well, you just have to have a mold.
I mean, with the traditional manufacturing methods.
More labor intensive.
Yeah.
Thus making the project a significant amount more expensive.
Yeah.
Right? So, the idea is that they're building underwater sea structures.
Yes.
And in order for a reef to thrive, number one, you need to have good places for fish to hide.
Yes.
The small fish will attract the medium fish. The medium fish will attract the large sharks and stuff like that. I'm oversimplifying. So if there's any biologists watching, I apologize for making that overly simplified.
Well, it becomes an ecosystem, a culture.
Yeah.
Or something.
And then from there, the reef needs a structure for the corals to grow on. Usually there needs to be calcium in the well, there's calcium in the ocean.
Yeah.
Right? But a lot of reefs grow off calcium. And cement is apparently a great substrate. They will grow right over cement. Corals will grow over cement like it's no problem.
Interesting.
As if it was already there. Like they'll grow over rocks and stuff too, right? And so it's an actual natural fit for you to use cement as a way to build the structure for the small fish that allows them to hide. Then it's a substrate for the corals to grow on top of that. And as the corals grow, it creates even more space for the fish to hide.
Yeah.
So it's a bit of a big feedback loop.
Yeah.
I can't imagine the application being super, super big. It's super niche.
Yeah.
And the technology is the same technology that they would use to build houses.
Yeah.
So large crane, 3D printing, concrete deposition arm comes down. And they just essentially weave the structure out.
Yes.
There's a really cool side effect of concrete. It's really, really basic, alkaline. And the bleaching of corals is a cause of temperature and acidification.
Okay.
And acid base turns neutral.
Yeah.
So I don't think they can fix that problem with adding concrete to the ocean. I don't think that's a good idea. But it's a little bit of a side effect that comes out of it.
Oh.
Just thought people may want to know.
Right. Yeah, it's an interesting fact. I would have known.
Yeah. So the article, I think Andy, you pulled it up. I don't know the company off the top of my head.
I believe they're called Xtree, Xtree. Apparently, it's a French company once again. I don't know if we pronounce it that way, but pardon me if I pronounce it wrong and I butcher it. Yeah. But essentially, they are also looking into this. It's like an artificial reef that they 3D print. But this time, instead of concrete, they use something else. It's a different, it's a biodegradable material. Yeah. Which,
it's still paste driven.
Yes.
Yeah.
So essentially what happens, I believe, is the same thing happens that the fish hides in it. It fosters coral reef to sit on it, grow on it, and then afterwards, once it gets the coral reefs get stable enough, or just when time passes and the coral reefs grow, the biodegradable material will actually biodegrade. Right. And in the end, it'll just be gone. It'll just be coral reefs.
I would imagine that they're using like oyster shells and organic material as the base. And as with anything underwater, it erodes over time.
Yes.
And so you do want the corals to be the infrastructure of a reef. You don't want it to be like concrete.
Well, concrete will always be there.
Even then, it will erode over time. You'll be surprised.
A very long amount of time.
But the idea, I think, is super sound.
Yeah.
It is a very interesting use case for, like, I'm call it large format paste extruder machines. And the environmental impact application makes total sense.
Yeah.
Right? Not every application needs to have a dollar figure out. Yeah. Especially for conservation work. A lot of it is based off the capital in. Yeah. Right? And it is important. I mean, once we lose the reefs, we lose the reefs. Yeah. It's not coming back for a while, if not ever.
Yes.
And that means a loss of biodiversity.
Yeah.
We actually do not know what happens to fish when they lose coral reefs and places to hide. Like where do all the small fish go?
Well, they'll probably get eaten.
Yeah.
I would assume.
I mean, and then once they're all gone, where does the big fish get their feet? Like, you know, there's a domino effect that happens when an ecosystem disappears like that. And this, for me, is an environmental kind of conservation application.
Mm-hmm.
Great use of the technology, I think, because anytime conservation has a large capital requirement, they can do less.
Yeah.
So the more that they can do, the more impact it's going to have.
Yeah.
So I think it's good.
Yeah. There's one more thing that actually 3D printing puts impact on the environment is apparently they've been, I don't know who's doing this. I just came across this article saying that they've been actually turning ocean waste into wearable fashion.
Huh. Like waste plastic.
Yeah. So it was just like earlier Adidas was using these fishing nets to make like a concept shoe.
I mean, there's a lot of plastic in the ocean.
Yeah. So it's a good application or a good way to go through.
Yeah, I think it runs into the same scenario as recycling filament.
Yes.
Where for those viewers that do not know, filament single-handedly accounts for, I would say, like a good 60-70% of a machine's reliability.
Mm-hmm.
If you have non-pure filament or particles in your filament or dust in your filament or anything that's a contaminant that will block the nozzle of a filament, it jams.
Yeah.
And so there's probably a lot of washing of the plastic involved. There's a lot of cleaning of the plastic involved, and getting that quality assurance down packed is going to be pretty important. But
it's a cool way to eliminate plastics from our environment, right?
Yeah. Yeah, I think we've seen this couple projects in the past that have taken marine plastic and trying to do something with it.
Mm-hmm.
We've seen some of them. There's actually a couple companies, or maybe they're researchers, maybe not companies, in Vancouver that did that early on. But the issues was contamination. And I mean, that will forever be the biggest issue with filament, right? It's contamination.
Yeah, until we find a better method of filtering all the contamination.
Yeah.
Or how many times it has to go through the filtering system, I don't know. But unless that's determined, I don't think we'll be seeing a lot of these yet. But there has been people that is trying to go through this route.
You know what? The interesting thing is, with regards to recycling material, is that we're thinking about nozzle sizes of 0.3, 0.4, 0.5 millimeters, which are like tiny. I don't know what that is in imperial.
No idea.
It's tiny. And if we were to scale this, like if the recycled materials was positioned for a market that uses larger diameter,
then it wouldn't even matter.
Exactly. So if there is a machine big enough to print with, like, I don't know, a 1 millimeter or even a 2 millimeter diameter orifice, nozzle diameter, and you're printing giant furnitures, the contamination would not even exist. You would still want to filter, but you would not need to filter nearly as much as you would for 0.035. Sorry, 0.35.
Yeah.
There we go.
But then one thing you'll probably have to worry about is the composition of it. Would some parts of your wall, that's per se, let's say if we're printing a house, would some part of your walls be more susceptible to whatever? Depending if there's a concentration of whatever material is in it.
I think that the housing and the wall stuff will be concrete, to be honest. I mean, they can mix recycled plastic into that, I suppose. But we're talking about taking the plastic from the ocean.
Yes.
Distilling it down to its, different components, polypropylene, PETG, polycarbonate, whatever.
So you don't think it's going to be a whole mix of everything?
I don't think so. The recycling plants of today break out the different plastics already, right?
Yeah.
So it'll probably follow a similar scenario to that. And then it would be turned into probably pellets.
Individual. Okay.
And then the pellets then gets mixed with virgins. Yeah. So it makes a lot of sense, actually. If there's a way to get all that plastic out, which is difficult.
Yeah.
Ocean is pretty big.
Yeah.
But nonetheless, it's a challenge I think our generation and the future generation needs to tackle.
Well, yep. Well, if planet Earth is supposed to be,
habitable for another 2,000 years,
that's something that's a problem that we have to look at.
For sure. I think so.
Population's always going up, more waste, more everything. We have to find a more sustainable method
of making things.
Yeah.
I totally agree.
And back to our first subject, instead of one-time use stuff, we want to be concentrating on making stuff that you can actually use more than once.
And that is where the industry of manufacturing is at.
Yeah.
But I think we have a good opportunity to get there.
Mm-hmm.
I think the landscape of manufacturing is changing with technology emerging.
Yeah.
And there are crazy enough people that will look at the ocean.
What can I do with it?
And say, how can I help?
Yeah.
And that's the first step to talking about and really addressing these elements.
Mm-hmm. Well,
cool.
That's everything for this episode. If you have any questions, feel free to put it in the comment section below. And also remember to subscribe and press the bell button also below this video to stay tuned for the next video. And for people that are not on YouTube, you can also listen to this on Spotify and Anchor. So remember to do that too. And we want to see if you guys have any ideas regarding 3D printers and 3D printers and the environment, application and impact. Like, have you guys come across something cool? Also put that down in the comment section below.
Mm-hmm.
And other than that, thanks for watching.
Yeah, we'll see you guys next time.
Yep.
Cheers.
Bye.